So today we're going to be drawing bond line formulas. Let's start with the first molecule is CH3, CH2, OCH3. And so normally you would start with, this carbon backbone with an oxygen in the middle, and it would look something like that, right? And then you'd have your hydrogens all coming off. I'm not going to draw them all right now, because that's going to be lone pairs. And these would all be hydrogens, right? And so this is just a lot of time and drawing, and so the reason we have bond line formulas is so we don't have to spend our time drawing every carbon and every hydrogen. They're going to become implied. And so for carbons, they just become the ends and corners of our molecules. So this molecule has 1, 2, 3 carbons and an oxygen in the middle. So we're going to start by just drawing a line, and this is actually going to represent 2 carbons. 1, 2 carbons. Our line is going to go to our oxygen, and our other line is just going to end. And that's going to be our 3rd carbon. So what this actually looks like is carbon, carbon, oxygen, carbon. And that's the same thing as up here, right? But we're not drawing the carbons. We're implying them with the ends of the line, right? The ends of the line and the corners. So this corner right here implies that there's a carbon there. And we don't have to draw the hydrogens at all. And so while this is technically correct, I'll draw the cleaner version for you. The answer to this becomes just that. This is the correct answer. And you can always my trick to help draw is counting. So every time you draw a line, you count 2. You don't start like 1, 2, 3. It's 2, 3, 4, because you end up with 1, 2, 3, 4 carbons. And this is butane right here. So let's start with our other molecule. We have CH3, but that is actually, there's 3 of them. We have a carbon, and we have a hydroxy group. And so we're going to start with this group here. So here is a methyl group. That's 1 carbon, and we have 3 of them. So we're going to connect all of them. So that's 3 methyl groups. There's a secret carbon, remember, on every single one of these. And we're going to link that to an oxygen. So this is our carbon. This is our 1, 2, 3 methyl groups connected to that 1 carbon right there. We have an oxygen, and we have a hydrogen, and this is our hydroxy group. So that is how you draw this structure right here. For our next molecule, we have the molecular formula CH3, CH2. There's 3 of those, and Cl, chlorine. So the way we're going to draw this is we're going to start with our first group is the first carbon, and there's, imagine, 3 hydrogens coming off of this 1 carbon right here. And now we have 3 CH2s, and when you see CH2s, you know those are usually in the middle of an alkene, or alkane I should say. And so you have that first end here, you have 2, 3 of those carbons here. So you have the first carbon, 1. You have 1, 2, 3 of these. You have 1, 2, 3. And so you're done with your carbon chain, and we're just going to connect to 1 more chlorine. So again, you have 1, 2, 3, 4 carbons, and if you add all the carbons up in here, you have 1, 2, 3, 4. Remember, there's 3 of these carbons, and the hydrogens are all implied along here, and then you have your chlorine stuck onto the end. So it's just like this right here. Let me circle this so you know these are the final answers. Our final molecule that we have to draw has the molecular formula CH2O, CH2 again, CH2 again, CH2 2 more times, I believe.
I did.
And then it has this weird arc, kind of going across from the beginning to the end. And this arc is going to represent a ring. So we can count our carbons. We have 1, 2, 3, 4, 5 carbons. That's going to mean we have a 5-member ring, except we have an oxygen here. So it's going to be 5-carbon ring with an oxygen in the middle. It's going to kind of look like a hexagon. So we have 1, 2, 3, 4. And that's 5 carbons, if you think about it. 1, 2, 3, 4, 5. I'll write those out to you. And so this arc means that we're going to have a ring. And so I've drawn out the 1, 2, 3, 4, 5 carbons, right? We have 1, 2, 3, 4, 5 carbons in this molecule. But we've also got an oxygen. And so this is not a pentane. This is a pentane molecule because you have 1, 2, 3, 4, 5. We're not looking at that. We're looking at a 5-membered ring with an oxygen. So we're going to close this ring with an oxygen. We have our 1, 2, 3, 4, 5 carbons and our oxygen. So our final answer is going to look like this. I'll write it clean for you. An oxygen at the top. And remember, every turn represents a carbon. So that's how you know there's a carbon at these corners here, but there's an oxygen at the top. That is your final answer for that molecule.